Hi all, this is the second part of civil engineering basic knowledge. Here in last video we have discussed on the basics of the slab, and in this video we will be discussing on the beam. Okay, here the beam is a line element which is to be used in the structures like buildings and bridges mainly. Okay, any of the steel structure also we can call it as the beams itself, purlins, something, the different names are there. When it comes to beam, the depth of beam mainly depends on the L by D ratio. It is nothing but length to the depth ratio. Okay, the ratio is from the IS 456. It is for simply supported sections it is 20, and for cantilever sections it is 7, and for continuous sections it is 26 as per IS 456. Okay, based on these guidelines only I will be finding, we need to find out the depth of beam. For example, if a beam is there between the two supports which is having the span of 6 meter, okay, if the span is there, based on this span is equal to, that is L is equal to 6 meter, based on this if it is simply supported, L by D is 20, so depth will be 6, that is L by 20, this is equal to 6000 divided by 20. Something in this way will be finding the depth of beam or the sections of beam. Okay, whenever you go for the beam, there will be a load and we need to design. Okay, and the beam is a flexural element. Okay, and it's a, if you are using Fe415 steel, the minimum reinforcement or steel in the beam is 0.21%, and the maximum reinforcement is 4% of the total cross section area. In this way we will be finding the reinforcement, okay, or the limits of the reinforcement in a beam. And for Fe500 grade there is the equation AS by BD, something equation is there, is equal to, that means something, the equation is there in the IS 456. It is, when you refer IS 456 will come to know the equation of minimum reinforcement in a beam. Okay, and this is a flex, as I said, it is a flexural element. If it is simply supported or two supports, if it bends in this manner, obviously under the forces the beam will bend in this manner. So top portion, that is top fibers are under compression and bottom fibers are under tension. That means with respect to this one, this we call it as the neutral axis. With respect to neutral axis, the bottom fibers will under tension or tensile stresses and top fibers are under compressive stresses. When it comes to the cantilever portion, so when it bends, when you apply force, it will be bent in this direction. So neutral axis will be here. Okay, so here the top fibers are in tension and bottom fibers are under compression. And when it comes to the continuous beam over several supports, the series will be there, so it bends. Beam will bend in this manner. Okay, so here tension, compression, and at support tension will be at top and compression will be at bottom, whereas at midspan tension will be at bottom and the compression will be at top. The series of tension compression will plays a role here. Okay, this is all about the basics of the beam, and the minimum reinforcement is this much and maximum reinforcement is this much. Okay, and I have uploaded how to design a beam. A video is there on my channel. If you want, you can go and check. It is a video how to design a beam. Okay, apart from this we have two types of beams. Okay, apart from the it's a nature of the support, we have two types of beams, that is singly reinforced and doubly reinforced. Singly means we have discussed on this also, singly and doubly. Okay, here the main reinforcements will be there at top and bottom, especially in doubly, whereas especially in singly these are the nominal reinforcements, or we call it as hanger bars, only to hang the stirrups, and these are the main reinforcements. This we call it as AST. Whereas here in doubly these are the main reinforcement, AST, whereas in the top fibers also this we call it as ASC. These are also a main reinforcement to resist the compressive stresses. As we know, the top fibers are in compression and bottom fibers are in tension. If the compressive stresses exceeds the capacity of concrete in the compression zone, we need to introduce the additional reinforcement, we call it as ASC. Whereas here in the singly reinforced beam, the compressive stresses are well within the limit, that means it is less than the capacity of the concrete. Here we can easily we can easily judge based on moment. This is the moment acting, this is the limiting moment. Okay, if the moment acting is less than limiting moment, so we call it as singly reinforced, and if mu is greater than that moment acting is greater than limiting moment, so we call it as the doubly reinforced beam. Okay, if here we have uploaded the video on design of singly and doubly reinforced beam. Just go through my the previous videos on my channel, you'll come to know. Okay, this is all about the basics of the beam design, okay, or the basics of beam. Okay, mainly there are different materials are there. Beam may be of wood, it may be of concrete, it may be of steel, it may be of stone. Many structures we have seen, many temples in India are made up of the stone, and wooden. Many old houses you might have seen the horizontal members are made up of wood, And nowadays the new buildings or RC buildings, here you can see the concrete beam, and the industrial structures or industrial sheds are made up of the steel structure. Okay, so there you can see the steel structures or steel beams. Okay, different types of beams will be there nowadays. The composite sections are also coming. Okay, so here there are 4 different types of beams can be used based on the material. This is based on the support, and next one, this is based on the stress distribution. Okay, in this way we will be dividing the beam. This is all about the beam, that is basics of beam. Okay, we'll discuss more on this, not only on the other structural elements. We'll be discussing another session on beam itself. Until then, thank you, and don't forget to check the design videos on beam, that is design of singly and doubly reinforced beam. Thank you.